Hi guys, this is the EdExcel AS Level Maths Paper 1 from the October 2020 series, and in this paper we will be taking a look at the Pure Maths section. Question number 1. A curve has equation y equals 2x cubed minus 4x plus 5. We have to find the equation of the tangent to the curve at the point P, which has coordinates 2, 13, and we have to write our answer in the form y equals mx plus c, where m and c are integers to be found. Now, when we see the word tangent, we should instantly be thinking to ourselves, we need to find out what dy over dx is. And this will serve as a reminder to differentiate the 2x cubed minus 4x plus 5. And now if we work out what dy over dx is, that will tell us the gradient function. So dy over dx, that's equal to, if I differentiate the 2x cubed, I get 6x squared. If I differentiate the minus 4x, I get minus 4. And if I differentiate the 5, I get 0. So here, our gradient function is 6x squared minus 4. And we can now find the gradient of the tangent by substituting x equals 2 into this gradient function. So when x is equal to 2, dy over dx, that's equal to 6 lots of 2 squared minus 4, which is 20. So the gradient of the tangent is 20. And now to find the equation of the tangent, we can use y minus y1 equals m lots of x minus x1. So we see that x1, that's equal to 2, y1, that's equal to 13. We see the 20 represents the gradient of the tangent, which is m, and therefore substituting these known values, we end up with y minus 13 equals 20 lots of x minus 2. And if we expand and simplify, writing our answer in the required form y equals mx plus c, we can therefore conclude y is equal to 20x, and then here 20 times by minus 2, that's minus 40, and adding the 13, we end up with minus 17. So the equation of the tangent is y equals 20x minus 17. Of course, the constant m, that's 20, the constant c, that's minus 17. Question number 2. In this question, the unit vectors I and j are due east and due north respectively. A Coast Guard station O monitors the movements of a small boat. At 10 o'clock, the boat is at a point 4i minus 2j kilometers relative to O, and at 12:45 p.m. the boat is at the point minus 3i minus 5j kilometers relative to O. The motion of the boat is modelled as that of a particle moving in a straight line at constant speed, and for part A, we have to calculate the bearing on which the boat is moving, giving an answer in degrees to 1 decimal place. I think it will be a good idea to sketch this problem. So what we see over here At 10 o'clock, the boat is at this point 4 minus 2, and at 12:45, the boat is at this point minus 3 minus 5. And the boat essentially starts here at O, it goes to this point at 10 o'clock, and then at 12:45 it's at this point. Of course, 4 minus 2 and minus 3 minus 5 are relative to O. And we're going from here to here, so we're moving from here to here. And we're calculating the bearing from here to here. So when we talk about the bearing, of course, I and J represent east and north respectively. Remember, with bearings, we measure from north and go in a clockwise direction. So the angle we want is this angle over here. And of course, to calculate this angle, we have this 180 degrees, which takes us from north to south. And then we have this extra bit over here. And for us to calculate that extra bit, we would have to use trigonometry. Going from 4 to the minus 3, we move 7 units in the west direction. And to go from the minus 2 to the minus 5, we move 3 units in the south direction. So let's add this to the diagram. So we see here we travel 7 kilometers west and 3 kilometers south to arrive from this point to this point. Let's emphasize we're moving in this direction. And you'd also notice this angle here, from here to here, is the same as this angle here. We'll call it alpha. And to calculate this angle, we can use trigonometry. So, what we have over here then, the bearing, that's equal to the sum of the 180 degrees, which takes us from north to south, plus this angle here. And this angle over here, alpha, and the reason these angles are the same is because they are alternate z angles. That's the inverse tan of 7 over 3. And working this out to 1 decimal place, we have 180 plus the inverse tan of 7 over 3, which is 246.8 degrees. So here we have 246.8 degrees. And now for part B, we have to calculate the speed of the boat, giving your answer in kilometers per hour. Well, for us to calculate the speed, we need both the distance and the time. The distance we can find using Pythagoras. So the distance, that's equal to 7 squared plus 3 squared square rooted. Okay? And it turns out the distance, that's root 58. Okay? And the time, from 10 o'clock to 12:45, the time, that's 12:45 PM, take away 10 o'clock AM. So here we have 2 hours and 45 minutes. Now, of course, paying attention to the units, we have kilometers per hour, so we need to convert the 45 minutes into hours, and you'd find here the time therefore is 2 hours 0.75 hours as well, which gives us 2.75 hours. And therefore, the speed, that's equal to the distance over the time. So speed, that's equal to the distance over time. So we have the distance, that's root 58. We have the time, 2.75 hours. So therefore, the speed, we can work that out. We have root 58 over 2.75, which to 3 significant figures is 2.77. So we have 2.77 kilometers per hour to 3 significant figures. Question number 3. In this question, you must show all stages of your working, and solutions relying on calculator technology are not acceptable. For the first part, we have to solve the equation x times by root 2 minus root 18 equals x, writing the answer as I said in simplest form. So what we have over here is root 2 x minus root 18, and this is equal to x. Now we have here a linear equation, so let's gather all the terms involving an x on one side, and all the terms not involving an x let's take to the other side. So we have root 2 x minus x, this is equal to root 18. And hopefully you can see on the left hand side we can factorize out an x. So we have x lots of root 2 minus 1. And on the other side we still have this root 18. And for us to find out what x is, we would have to divide both sides by root 2 minus 1. So x is equal to root 18 divided by root 2 minus 1. And for us to find out what x is, we would have to multiply both sides, both the top and the bottom, by the conjugate of the bottom. So we will multiply both the top and the bottom by root 2 plus 1. Okay? And the reason I want to do this, the question specified to me, I must show all my stages of working. So when we come to find out what x is, we can use our calculator. Root 18 over root 2 minus 1, that's 6 plus 3 root 2. So x is equal to 6 plus 3 root 2. And now for the next part of the question, we have to solve the equation 4 to the power of 3x minus 2 equals 1 over 2 root 2. Now, what we want to do in this question is make sure we have the same base number. And then from that, if we can write everything in terms of 2 to the power of something on both the left hand side and the right hand side, we can then compare the powers to find out what x is. So we begin of course with the 4 to the power of 3x minus 2, and this is equal to 1 over 2 root 2. And the 2 root 2 I'm going to rewrite as 2 to the power of 1 times by 2 to the power of 1/2. The reason for this will become apparent shortly. Now 4, we can rewrite that as 2 squared. So we have 2 squared to the power of 3x minus 2, which is equal to 1 over 2 times by 2 to the power of 1/2. And because we have the same base number here, we can add the powers. 1 plus 1/2, that's 3 over 2. So we have 1 over 2 to the power of 3 over 2. Now on the left hand side, we have a power raised to another power, so we can multiply. So we have 2 to the power of 2 lots of 3x minus 2. And this is equal to 1 over 2 to the power of 3 over 2. And we can rewrite this in indices form. We can rewrite this as 2 to the power of minus 3 over 2. Now we have the same base number on both sides. We can now compare the powers to find out what x is. First of all, let's expand the brackets here. So we have 2 to the power of 6x minus 4, and this is equal to 2 to the power of minus 3 over 2. And now comparing powers, we see that 6x minus 4, that's equal to minus 3 over 2. If I add 4 to both sides, we see that 6x, that's equal to 5 over 2, and therefore, dividing both sides by 6, x is equal to 5 over 12. Question number 4. In 1997, the average CO2 emissions of new cars in the UK was 190 grams per kilometre. In 2005, the average CO2 emissions of new cars in the UK had fallen to 169 grams per kilometre. Given that 8 grams per kilometre is the average CO2 emissions of new cars in the UK n years after 1997, and using a linear model, we have to form an equation linking A with n. Now, essentially, a linear model that will be of the form y equals mx plus c. But our variables are not y and x, they are a and n. We want to find an equation linking n with a. So for part A, hopefully you can recognize that this situation can be modeled as A equals mn plus c, where essentially m is the gradient and c is the A intercept. Now, in 1997, what we see over here, A is equal to 190 and n is equal to 0. Remember, n is the number of years after 1997, hence n is equal to 0. And with this, you can hopefully see, if we substitute into this equation here, 190 is equal to m lots of 0 plus c. In conclusion, c, that's equal to 190. And in 2005, we see here a is equal to 169 and n, that's going to equal 8. From 1997 to 2005, that's 8 years. And if we substitute these into this equation here, 169 is equal to m lots of 8 plus c. So we have 169 equals 8m plus 190. We wish to find out what m is. Of course, m, that's going to equal 169 minus 190 divided by 8, which is minus 2.625. So we have m, which is equal to minus 2.625. Okay, and knowing the value of m and c, we can therefore conclude a is equal to minus 2.625 n plus 190. For part B of the question, in 2016 the average CO2 emissions of new cars in the UK was 120 grams per kilometre. We have to comment on the suitability of our model in light of this information. Now, in 2016, we see that A is equal to 120 and N is equal to 19. Of course, we're going from 1997 to 2016. So in 2016, A is equal to 120 and N, that's equal to 19. Okay, and if we use our model, we can compare our value of A we get using the model with this value of 120. So perhaps if I rub this out, we're looking at what happens when n equals 19. And when n is equal to 19, A will equal minus 2.625 times by 19 plus 190. And if we work this out, so we multiply this by 19 and then add on 190, we end up with 140.125 grams per kilometre. And we see over here this value is greater than the 120 grams per kilometre previously mentioned, and therefore we can conclude the following. We can conclude that the model is not suitable because the model predicts a much higher value than this 120. Question number 5. Figure 1 shows the design for a structure used to support a roof. The structure consists of 4 steel beams AB, BD, BC and AD, and we're given that AB is equal to 12 meters. Let's just add this into the diagram. We have BC and BD, which are both equal to 7 meters. So here we have 7 meters, and here we also have 7 meters, and we have the angle BAC, which is 27 degrees. and we have to find to one decimal place the size of the angle ACB, which is this angle here. So to work out that angle, of course, we have a length opposite to that angle, and for this length we have an angle opposite to it, and therefore we can use the sine rule. So we have the size of the angle ACB, which we can find. So we have the sine of ACB over 12, and this is equal to the sine of 27 over the 7. And therefore we see from here that the sine of ACB, that's equal to 12 times by the sine of 27 over 7, and therefore hopefully here you can see ACB, that's given by the inverse sine of 12 sine 27 over 7. Turns out we get 51.1, etc. Now, if you actually take a look at this diagram, we have an ambiguous case. This angle can also be obtuse, and it makes sense in context if we think about how a roof support will actually look like. This angle will be the obtuse angle. So let's just store this value into A. The other angle we can possibly have will be 180 minus this, which is 128.8, etc. Let's store this into B. So therefore, the angle ACB, that's equal to 128.8, etc. degrees. Well, we have to give our answer to one decimal place, so it's equal to 128.9. Okay. Now, with that, for part B, the steel beams can only be bought in whole meter lengths, and we have to find the minimum length of steel that needs to be bought to make the complete structure. First of all, let's add this value of this angle into the diagram. Here we have a value of 128.9. Okay, and this remaining angle we can also find. We have a straight line here, so that angle, that will equal 180 minus the 128.9, which is 51.1. So we have 51.1 degrees here. Okay, and because we have an isosceles triangle in BCD, this angle over here is also equal to the 51.1. So this angle over here is also equal to 51.1 degrees. And with that, if we know what this entire angle is, that is the angle ABD, we can use the cosine rule to find out the length AD which will help us determine the total length of this steel structure. Now this angle over here, angles in a triangle add up to 180. So 180 minus 2 lots of that 51, that angle is 77.7, etc. So here we have 77.7 degrees, and therefore this missing angle here, that's equal to, well, first of all let's store this into C. This missing angle here, that's equal to 180 minus the 27 from here minus this 128.9, so that was B. Turns out we get 24.1, etc. So here we get 24.1 degrees. And therefore, this total angle, let's add it to the diagram. This total angle will be 77.7, etc. plus this 24.1. So here we're going to add on this C. We get 101.8, etc. And therefore we can use the cosine rule to find out the length AD. So for part B, AD squared, that's equal to AB squared plus BD squared. So here we have AB squared plus BD squared minus 2 lots of AB times by BD times by the cosine of that angle ABD. So we have over here AB squared, so here we have 7 squared plus 12 squared minus 2 times by 7 times by 12 times by the cosine of 101.8, etc. And if we work all this out, so we have the cosine of this angle, and then we multiply it, well, we have 7 squared plus 12 squared minus 2 times by 7 times by 12 times by the cosine of this, so we get 227.6, and therefore AD, that's equal to the square root of this, which is 15.08, etc. So let's add this to the diagram. Here we have 15.08, etc. meters. And therefore, the total length that's equal to the 12 plus the 7 plus this other 7 plus this 15.08, etc. So here we add on 14 plus 12, so we get 41.08, etc. And therefore the minimum length that will be 42 meters. Question number 6. For part A, we have to find the first 4 terms in ascending powers of x in the binomial expansion of 1 plus kx to the power of 10, where k is a non-zero constant, and we have to write each coefficient as simply as possible. And if you go to the formula book, The binomial expansion formula is given over here. Okay, so this over here is the formula for the binomial expansion. So, using the binomial expansion for part A, we have 1 plus kx to the power of 10. Our first term, that will be 10 choose 0 multiplied by 1 to the power of 10 lots of kx to the power of 0. Our second term, we have 10 choose 1 lots of 1 to the power of 9 lots of kx to the power of 1. Our third term, we have 10 choose 2 lots of 1 to the power of 8 lots of kx to the power of 2. And our fourth term, we have 10 choose 3 times by 1 to the power of 7 lots of kx to the power of 3. And we can carry on, but there's no need because the question said find the first 4 terms. Now 10 choose 0, that's 1. So here we have 1 times by 1 times by kx to the power of 0. This thing is also 1. Our first term is 1. For our second term, well, 10 choose 1, let's work that out. So here we have 10 choose 1, that's 10. So we have 10 times by 1 times by kx. For our third term, we have 10 choose 2 times by 1. So 10 choose 2, that's 45. And then we have kx all squared, which is the same as k squared, x squared. And then 10 choose 3, that's 120. So we have 120 times by k cubed, x cubed. And of course we can continue, but there's no need. The question only asked for the first 4 terms. Now for part B of the question, given that in the expansion of 1 plus kx to the power of 10, the coefficient of x cubed is 3 times the coefficient of x, we have to find the possible values of k. Well, if the coefficient of x cubed is 3 times the coefficient of x squared, the coefficient of x cubed, remember if k is a number, the coefficient of x cubed, that's 120 k cubed. And the coefficient of x, the number in front of the x, that's 10k. And we see here that this is 3 times the coefficient of this. So we have 120 k cubed, which is the coefficient of x cubed. That's equal to 3 times by the coefficient of x. The coefficient of x is 10k. So here, that's the coefficient of x, and we multiply this by 3. And from this, we can form an equation, of course. 3 times by 10, that's 30. So we have 120 k cubed equals 30k. Dividing both sides by k, and then dividing both sides by 30, we see that k squared, that's equal to 1/4, and if I square root both sides, k, that's equal to plus minus 1/2. Question number 7. Given that k is a positive constant and the integral between 1 and k of 5 over 2 root x plus 3 with respect to x is equal to 4, we have to show that 3k plus 5 root k minus 12 equals 0. I think it will be a good idea to rewrite the 5 over 2 root x as 5 over 2x to the half. So for part A, we have the integral between 1 and k of 5 over 2x to the power of 1/2 plus 3. And we know that this is equal to 4. And what this is equivalent to, this here is equivalent to the integral between 1 and k of 5 over 2 x to the minus 1/2 plus 3. And of course this is equal to 4. Now when we integrate, we add 1 to the power and then divide by the new power. So if I add 1 to the power here, we have x to the power of 1/2, and then if I divide by the new power, 5 over 2 divided by 1/2, that's 5. And then if I integrate 3, I get 3x. And we wish to evaluate this in between 1 and k. And we know that the result of all this is 4. So, for the upper limit, we have 5k to the power of 1/2 plus 3k. And for the lower limit, we have 5 times by 1 plus 3 times by 1. So we have 5 plus 3. And this is equal to 4. Now, 5k to the half, I'm going to rewrite that as 5 times by the square root of k. And then we add on 3k, and then here we have minus 8, and then if I subtract off another 4, we get minus 12. And this is equal to 0. And that's exactly what we wanted to show. So let's just rewrite this as 3k plus 5 root k minus 12 equals 0. Now for part B, hence using algebra, we have to find any values of k such that the integral between 1 and k of 5 over 2 root x plus 3 with respect to x is equal to 4. We have to use our result in part A. And hopefully here you can see we have a hidden quadratic, because squaring the root k will give us k. Perhaps if we rewrite this, we have 3 lots of root k squared, which is the same as k, and then we add on 5 lots of root k minus 12, and this is equal to 0. Hopefully you can see we have a hidden quadratic. The way we approach this question, we can make a substitution. So if we let t equal root k, we have 3t squared plus 5t minus 12 equals 0. And we can factorize this. We can factorize this as 3t minus 4 lots of t plus 3. And all this is equal to 0. So therefore, t, that's equal to 4 over 3 or minus 3. And therefore, we see that root k is equal to 4 over 3 and minus 3. And in conclusion, k is going to be equal to 16 over 9. And that's because k must be greater than 0. We have a positive constant. Now, a reasonable question would be, why didn't we consider this minus 3 when I squared? First of all, from here you can hopefully see k is equal to 16 over 9 and 9, and of course square rooting, we end up with the 4 over 3 and the minus 3. Of course, we could have minus 4 over 3 and 3. The reason we choose k equals 16 over 9, let's try to work out this integral on our calculator. We have the integral of 5 over 2 times by the square root of x plus 3 in between 1 and 16 over 9. We end up with 4. But if instead over here I have a 9, I end up with 34, which is incorrect. Hence over here we end up with 16 over 9 as our only solution. Question number 8. The temperature theta degrees C of a cup of tea t minutes after it was placed on a table in a room is modelled by the equation theta equals 18 plus 65 e to the minus t over 8, where t is greater or equal to 0. We have to find, according to the model, the temperature of the cup of tea when it was placed on the table. And it's placed on the table when t is equal to 0. So for part A of the question, we have given to us theta, which is equal to 18 plus 65 e to the minus t over 8, and when t is equal to 0, theta is equal to 18 plus 65 e to the 0, so we have 18 plus 65, which is 83. So we have 83 degrees C. Now for part B of the question, we have to find the value of t to 1 decimal place when the temperature of the cup of tea was 35 degrees. So this time for part B, we're looking at the time when theta is equal to 35. So we have here, when theta equals 35, we have 18 plus 65 e to the minus t over 8, which is equal to 35. So we have e to the power of minus t over 8, that's equal to 35 minus 18 over 65. So here we have e to the minus t over 8, which is equal to 17 over 65. And if we log both sides, we see that minus t over 8 is equal to the natural log of 17 over 65. So t, that's equal to minus 8 times by the natural log of 17 over 65, which to 1 decimal place, we have minus 8 times by the natural log of this, which is 10.7 minutes to 1 decimal place. Now for part C of the question, we have to explain why, according to this model, the temperature of the cup of tea could not fall to 15 degrees C. Well, here we're looking at the long-term behaviour. We're essentially looking at what happens as t gets very large. So for part C, as t gets very large, in other words as t tends towards infinity, you'd hopefully see here e to the minus t over 8 also tends towards 0. And therefore, what we have if we use our model, we have 18 plus 65 times by 0. So here, theta will equal 18 plus 65 times by 0, which is 18. So we have 18 degrees C, which is greater than the 15 degrees C. So therefore, the minimum temperature is 18 degrees C. So let's just write this down. The minimum temperature is 18 degrees C. And now for part D of the question, the temperature mu degrees C of a second cup of tea t minutes after it was placed on a table in a different room is modelled by this equation mu equals a plus be to the minus t over 8, where a and b are constants. Figure 2 over here shows a sketch of mu against t with two data points that lie on the curve. We've got this point here, 0.94, and this other point, 8.50. The line L, also shown in figure 2, that's here, is the asymptote to the curve. Using the equation of this model and the information given in figure 2, we have to find an equation for the asymptote L. And hopefully, if we take a look at this equation here, straight away you can see the asymptote corresponds to A, because this value of A simply represents a translation by vector 0A. We've moved A units in the mu axis. So here is our asymptote L, okay, which has equation mu equals A, okay. So, for us to find that, we can simply substitute in these points given into this equation here. So, we have mu, which is equal to A plus B e to the minus t over 8. Considering this point 0.94, we have 94 equals A plus B e to the power of 0. In other words, 94 is equal to A plus B. And if we consider the other point, it's 850. So considering this point, we have 50 equals A plus B e to the power of minus 8 over 8, which is minus 1. I'm going to rewrite this as 50 equals A plus B over E. Essentially, we want to find out the value of A, and I explained that earlier over here, where I mentioned the equation of the horizontal asymptote, that's mu equals A. Now for us to find out what A is, if I get the B's to be the same, we can subtract the equations. And the way I can do that is multiplying both sides of this equation by E. So here we have 50 E equals A E plus B. And now if we subtract these equations, 50E minus 94 is on the left hand side. So here what I'm going to do is equation 2 minus equation 1. So I have 50E minus 94. And this is equal to AE minus A. And of course B minus B is 0. And on this side I can factorize out an A. So I have A lots of E minus 1 and on this side I have 50e minus 94. In conclusion, hopefully here you can see mu, which is equal to a, that's equal to 50e minus 94 over e minus 1. Okay. And that's the end of this question. Question number 9. Figure 3 shows part of the curve with equation y equals 3 cos x, and the point P, which has coordinates CD, is a minimum point on the curve, with C being the smallest negative value of x at which a minimum occurs. And we have to state the values of C and D. Well, if this is the equation y equals 3 cos x, hopefully here you can see here at this point we have minus 360, and here at this point we have positive 360. Here we've got a minimum at minus 3 because the graph has been stretched by a scale factor of 3, and here we've got a maximum at 3. So hopefully you can see straight away that the point P has coordinates minus 180, minus 3. Okay, so therefore for part A you can hopefully see that C is equal to minus 180 and D, that's equal to minus 3. So P has coordinates minus 180, minus 3. Now for part B we have to state the coordinates of the point to which P is mapped by the transformation which transforms the curve with equation y equals 3 cos x to the curve with equation y equals 3 times by the cosine of x over 4, and then y equals 3 times by the cosine of x minus 36. And what you should recognize here, the transformations are being applied in the x and y direction, so therefore the order does not matter. First of all, if we consider this y equals 3 cos x going to the graph of y equals 3 cos of x over 4, hopefully here you can see that we have a stretch by scale factor 1 over a quarter in the x direction. Now 1 over 1/4, that's 4. So therefore you can hopefully see we've got a stretch by scale factor 4 in the x direction. So we multiply this x coordinate by 4. So therefore we're going to have minus 720 minus 3. And then for the next part we've got y equals 3 times by the cosine of x minus 36. So we're going from y equals 3 cos x to y equals 3 times by the cosine of x minus 36. And what you'd see over here is we have a translation by vector 36, 0. And therefore we add on 36 to this x coordinate here, so therefore the new point would be minus 144 minus 3. Okay, so going from y equals cos x to y equals 3 cos x to y equals 3 cos of x over 4, and then y equals 3 lots of cos of x minus 36, we see that we have two transformations going on. One of them is a stretch, and that takes into account the 3. The other, in this case, is a stretch in the x direction, and in this case we have a translation in the x direction. Now for part C, we have to solve for theta being in between 450 and 720, the equation 3 cos theta equals 8 tan theta. We have to give our solution to one decimal place. So for part C of the question, we have 3 cos theta equals 8 tan theta. And the first thing which you should think about, what is tan theta the same as? Tan theta, that's the same as sine theta over cos theta. So here we have 8 times by sine theta over cos theta. And on the other side we have 3 times by cos theta. And if I multiply both sides by cos theta, we end up with 3 cos squared theta equals 8 times by sine theta. Now, at this point, you should be thinking to yourself, which identity can I use? And generally speaking, we can replace the squared term, so we end up with one variable involving sine only. So we have 3 lots of 1 minus sine squared, of course, 1 minus sine squared, that's the same as cos squared. This is equal to 8 times by sine theta. So we have 3 minus 3 sine squared theta minus 8 times by sine theta. This is equal to 0. And therefore, what you can hopefully see from here then, we end up with 3 times by sine squared theta plus 8 sine theta minus 3 equals 0. Okay? And we can now factorize this. We can factorize this as 3 sine theta minus 1 lots of sine theta plus 3. And all this is equal to 0. And what you can hopefully see from here, we have sine theta equals 1/3, and here we have sine theta which is equal to 3. And of course, sine theta actually cannot equal 3 because sine can only be in between -1 and 1. So we're solving the equation sine theta equals 1/3. Now, having drawn the graph of sine x that intersects the line 1/3 as shown in this graph over here, we can find out the points of intersection. And remember, we want to solve for theta being in between 450 and 720. Okay? So the value that we want, 450, is over here. So the value that we want is this value here. And I'll illustrate that here. The value we want is this value here. So first of all, the inverse sine of 1/3, that's 19.4, etc. So this value here is 19.4, etc. So this value here will be 180 minus that, and this value will be 360 plus this. So let's do 360 plus this. We end up with 379.4. So here we have 379.4, etc. If I subtract 360, this value is 180 minus this, which is 160.5, etc. And then if I add on 360, I get 520.5, etc., which is this value. So therefore, to one decimal place, you can see that theta is equal to 520.5 degrees. to one decimal place. Question number 10. We have g of x which is equal to 2x cubed plus x squared minus 41x minus 70. And we have to use the factor theorem to show that g of x is divisible by x minus 5. Well, if we use the factor theorem, let's first of all find the value of x to substitute into g of x. We can find that out by setting x minus 5 equal to 0, which implies that x is equal to 5. And if we substitute this x equals 5 into g of x, and if we get a value of 0, we can conclude that x minus 5 is a factor of g of x, and therefore g of x is divisible by x minus 5. So g of 5, that's equal to 2 lots of 5 cubed plus 5 squared minus 41 lots of 5 minus 70, which is 0. And therefore, we can say, since g of 5 is equal to 0, it follows that x minus 5 is a factor of g of x, and therefore g of x is divisible by x minus 5. And now, for part B, hence showing all your working, we have to write g of x as a product of 3 linear factors. Well, here we have a linear term, and g of x is a cubic, and a cubic divided by a linear term will be a quadratic. So therefore, we can see for part B of the question, x minus 5 lots of some sort of quadratic, ax squared plus bx plus c. This will be equivalent to our cubic, 2x cubed plus x squared minus 41x minus 70. And to find out the values of a, b and c, we can compare coefficients. Of course, there are other methods of finding this quadratic factor. The method I'm going to use, compare coefficients. So if we compare coefficients, if we compare the x cubed terms, x times by ax squared gives an x cubed term, and on the other side we have 2. Perhaps if I colour code this, we have x times by ax squared, which gives the 2x cubed. Okay? And if we compare the x squareds, we'll do this in blue. We have this x multiplied by the bx, which gives an x squared term, so that therefore the coefficient of x squared would be b in that case. And then we also have this minus 5 being multiplied by this a. So we have b minus 5a, that will equal 1x squared. Okay? And we know that a is equal to 2, so we have b minus 5 lots of 2 equals 1, b is equal to 11. And if we now compare the number terms, on the left hand side we have c lots of minus 5, and on the other side we have minus 70. So we have over here minus 5c equals minus 70. C, that's equal to 14. Okay, let's just write all this in black. So that was b minus 5a equals 1. And knowing the values of a, b and c, we can therefore conclude that g of x, that's equal to x minus 5 lots of ax squared, so here we have 2x squared plus 11x plus 14, which we can factorize. So we have x minus 5 lots of 2x plus 7 lots of x plus 2. Okay? So therefore we've written g of x as a product of 3 linear factors. And now for part C of the question, we've got the finite region R, which is bounded by the curve with equation g of y equals g of x, the x-axis, and lies below the x-axis, and we have to use algebraic integration to find the exact value of R. And I think at this point it will be a good idea to sketch the curve. First of all, if we do sketch the curve, when x is 0, g of 0, that will equal minus 5, lots of 7, lots of 2, so here we have minus 70. And when g of x is equal to 0, we have x minus 5, lots of 2x plus 7, lots of x plus 2, which is equal to 0, from which we can see x is equal to 5 minus 7 over 2 and minus 2. Okay? So having drawn the graph, what the question is essentially asking for is the area under the curve below the x-axis, bounded by the x-axis and this equation. So essentially the question is asking for this area. So we want to find this area R. And the way we can do that is using algebraic integration. So we want to integrate between minus 2 and 5 g of x with respect to x. So if I actually work out that integral between minus 2 and 5, so we're integrating 2x cubed plus x squared minus 41x minus 70. Let's integrate as normal, so we add 1 to the power, divide by the new power, so here we end up with if I add 1 to the power I get 4, if I divide by the new power, here I get 1/2 x to the 4, then here I get 1/3 x cubed minus 41 over 2 x squared minus 70x. And we wish to evaluate this in between minus 2 and 5. Okay? So, for our upper limit, we have 1/2 lots of 5 to the power of 4 plus 1/3 times by 5 cubed minus 41 over 2 lots of 5 squared minus 70 lots of 5. And then for our lower limit, we have 1/2 lots of minus 2 to the 4 plus 1/3 lots of minus 2 cubed minus 41 over 2 lots of minus 2 squared minus 70 lots of minus 2. And if we work this out, so if I work this integral out, we have 2x cubed plus x squared minus 41x minus 70. And we're finding out this in between minus 2 and 5. It turns out we get minus 1715 over 3. Okay? And therefore, the area, we take the positive value of this, so we have 1715 over 3 units squared. Question number 11. For the first part, we've got a circle C1 which has equation x squared plus y squared plus 18x minus 2y plus 30 equals 0. And we've got the line L, which is a tangent to C1 at the point P, which has coordinates -5, 7. And we have to find an equation of L in the form ax plus by plus c equals 0, where a, b and c are integers to be found. Okay, now the way we can find out the equation of the circle in an alternative form, we can complete the square. So if we complete the square with the x terms, we have x plus 9 all squared, and then we subtract off the square of 9, which is 81. And then with the y terms, we have y minus 1 all squared minus the square of 1, so we subtract off 1, and then we've still got this plus 30, and this is equal to 0. So we've got x plus 9 all squared plus y minus 1 all squared, which is equal to 52. And hopefully here you can see that the centre has coordinates -9, 1. And the radius, that will be the square root of 52. And we want to find out the equation of the tangent to this equation of the circle at this point. So I think it will be a good idea to sketch what's going on. So we've got this situation on. We've got our centre -9, 1, and we've got this point -5, 7. And we want to find out the equation of this tangent to the circle. We first of all need to find out the gradient of the radius, and then recognise the gradient of the radius is perpendicular to the tangent, and from that we can find out the gradient of the tangent, and from that we can find out the equation of the tangent. So the gradient of the radius, that's equal to 7 minus 1 over -5 take away -9. It turns out we get 3 over 2. And therefore the gradient of the tangent, so the gradient of the tangent, that's equal to -1 over the 3 over 2, which is -2/3. And we can now find out the equation of the tangent using y minus y1 equals m lots of x minus x1. So using y minus y1 equals m lots of x minus x1, here this -2/3 will represent m, the gradient of the tangent. The -5 will represent x1, the 7 will represent y1. So therefore we have y minus 7 equals -2/3 lots of x plus 5. So we have 3y minus 21 equals -2x minus 10. And therefore, in conclusion, we have 2x plus 3y minus 11 equals 0. For the next part of the question, a different circle C2 has equation x squared plus y squared minus 8x plus 12y plus k equals 0, where k is a constant, and given that C2 lies entirely in the fourth quadrant, we have to find the range of possible values for k. Well, if you look at this diagram, the fourth quadrant is here. So here is where we have the fourth quadrant. Okay? And the circle lies entirely in this quadrant. So let's take a look at what we have already. For this part of the question, we've got so far x squared plus y squared minus 8x plus 12y plus k equals 0. And let's complete the square as usual to find the centre and the radius. We've got x minus 4 all squared minus 16 plus y plus 6 all squared minus 36 plus k equals 0. So we've got x minus 4 all squared plus y plus 6 all squared. This is equal to 52 minus k. So therefore, the centre has coordinates 4 minus 6 and the radius will be 52 minus k square rooted. And if we sketch a circle, we have to bear in mind that it's entirely in the fourth quadrant. So the circle looks something like this. So what we see over here then is our circle. It's got the centre at 4 minus 6 and it lies in this fourth quadrant. Okay, so here is the fourth quadrant. And for it to lie in the fourth quadrant, the radius must be less than 4. If it was equal to 4, the circle will touch the y-axis, and we don't want that. Otherwise it won't lie entirely in the fourth quadrant. So what we can say from that is, if C2 lies in the fourth quadrant, then the radius must be less than 4. So in other words, we have 52 minus k square rooted, which is less than 4. And from this it follows that 52 minus k must be less than 16, which in conclusion we can say k must be greater than 36. And we also know that the radius must be greater than 0. So we've got 52 minus k square rooted, which must be greater than 0, which implies that 52 minus k is greater than 0. In other words, k is greater than 52. Okay? So, having said that, we can therefore conclude from here that the range of values of k, we have 36, which is less than k, which is less than 52. Okay? So from here, sorry, this is less than 52. Question 12. An advertising agency is monitoring the number of views of an online advert. The equation log base 10 of v equals 0.072t plus 2.379, where t is in between 1 and 30 and t is a natural number, is used to model the total number of views of the advert v in the first t days after the advert went live. And we have to show that v equals ab to the power of t, where a and b are constants to be found, and we have to give the value of a to the nearest whole number and the value of b to 3 significant figures. So for part A, we begin with the log base 10 of v, and this is equal to 0.072 t plus 2.379. And if we anti-log both sides, we see that v is equal to 10 to the power of 0.072t plus 2.379. And if I tidy this up a bit, we can rewrite this as 10 to the power of 0.072t lots of 10 to the power of 2.379. We're just using the laws of indices there. And what we can do here is write down the value of 10 to the power of 0.072. So here we have 10 to the power of 0.072, which is the 1.18 to the power of t. Actually, I'll write this out in full. We can rewrite this as 10 to the power of 0.072 all to the power of t multiplied by 10 to the power of 2.379, and we saw that this value is equal to 1.18. So here we have 1.18 to the power of t multiplied by 10 to the power of 2.379, which is 239 to the nearest whole number. So A is equal to 239, B, that's equal to 1.18. So for part B, we have to interpret with reference to the model the value of AB. Well, if you actually look at AB, if you look at what we have over here, V equals AB to the power of t, for us to have this AB, you can hopefully see that t is equal to 1. So AB implies that t is equal to 1. And what does this tell you? Well, it tells us the following. So the value of AB is the total number of views one day after the advert was visible. Now for part C of the question, using this model we have to calculate the total number of views of the advert in the first 20 days after the advert went live, give you answer to two significant figures. So here we're looking at what happens when t equals 20. When t equals 20, using the model over here, we've got V equals 10 to the power of 0.072 times by 20 plus 2.379. So if we work out what V is, we have 10 to the power of 0.072 times by 20 plus 2.379. It turns out we get 6591.7, etc., which to three significant figures, V is equal to 6600. Okay. So we have this number of views. Question number 13. For part A, we have to prove that for all positive values of A and B, 4A over B plus B over A is greater or equal to 4. Now this is actually quite difficult. Whenever you face a problem like this, I recommend that you sort this bit out and then work backwards. Now what I mean by that, for part A, if we play around with this to end up at a final step, we can then work backwards from that final step. And we can do this on the side. So, if we start off with this 4A plus B, 4A over B plus B over A being greater or equal to 4, writing everything over a common denominator, the common denominator here would be AB on the left hand side. So we have 4A squared plus B squared over AB being greater or equal to 4. And maybe from here we can combine these together. So we have 4A squared plus B squared over AB being greater or equal to 4. So from here we can multiply both sides by AB. So we have 4A squared plus B squared being greater or equal to 4AB. I don't know where this is going to end up, but all I'm doing right now is just playing around with everything. Maybe if I subtract 4AB from both sides, I've got 4A squared plus B squared minus 4AB, which is greater or equal to 0. And you can probably factorize this as a perfect square. We can rewrite this as 2A minus B all squared, and all this is greater or equal to 0. And I don't know what else to do from that. But the point is over here to realize this over here, this is our starting point. Okay? And essentially, if we start off from here, we can essentially work backwards to end up at this step over here. And if we do that, if we start off with 2a minus b all squared being greater or equal to 0, we can expand this out. So if we expand this out, we have 4a squared minus 4ab plus b squared being greater or equal to 0. And if I take this over to the other side, we have 4a squared plus b squared being greater or equal to 4ab. And what we can hopefully see here then is, well, we know that a is greater than 0 and b is greater than 0. So if that's the case, what we can do is divide both sides by ab. So we got 4a squared plus b squared over ab. This is greater or equal to 4ab over ab. So we have 4a squared over ab, I'm just splitting up the fraction now, plus b squared over ab. This is greater or equal to 4. And then you can probably simplify all this to conclude that 4a over b plus b over a is greater or equal to 4. Okay? So that's how I would approach this question. And for the next part of the question, we have to prove by counterexample that this is not true for all values of a and b. Well, what we can do over here is choose a negative value for b, for example, and see what we'll end up with. For example, if you've got a equals 5 and b equals minus 1, on the left hand side, we have 4 times by 5 over minus 1 plus minus 1 over 5, which is minus 101 over 5, which if you want to work that out, that's minus 20.2. And on the right hand side, we've got this 4. And what you can see over here then is that in conclusion, we can see here that for a and b belonging to a set of integers can be positive or negative, 4a over b plus b over a being greater or equal to 4 is sometimes true. Of course it's true when a and b are both positive, but when, say, a is positive and b is negative, the result is not true. Question number 14. A curve has equation y equals g of x, and given that g of x is a cubic expression in which the coefficient of x cubed is equal to the coefficient of x, and the curve with equation y equals g of x passes through the origin, and the curve with equation y equals g of x has a stationary point at 2, 9, we have to find g of x. Well, for part A, what we have to do over here is first of all recognise we have a cubic, and if we have a cubic, g of x, that's going to equal ax cubed plus bx squared plus cx plus d. Okay? So here, g of x is a cubic expression, as we see over here. And we know that the curve passes through the origin, so at the point 0, 0, so this is because the curve passes through the origin, we've got 0 equals 0 plus 0 plus 0 plus d, so therefore d is equal to 0. So far we can say that g of x, that's equal to ax cubed plus bx squared plus cx. Okay? And we also know that the coefficient of x cubed is equal to the coefficient of x. So in other words, c is equal to a. So this comes from the idea that the coefficient of x cubed is equal to the coefficient of x. And if we replace c with a, we can therefore conclude g of x, that's equal to ax cubed plus bx squared plus ax. And we know that the curve has a stationary point at the point 2, 9. So that tells us that the curve passes through the point 2, 9. So at the point 2, 9, remember the curve passes through this point. We see here that we have 9, which is equal to a lots of 2 cubed plus b lots of 2 squared plus a lots of 2. So we can tidy all this up. We see that we have 8 plus 2 a's. So here we have 10a plus 4b, which is equal to 9. We'll call this equation 1. And we also know that the curve has a stationary point at the point x equals 2. So if we differentiate this, g dash of x, remember the word stationary point suggests to us that dy over dx is equal to 0, or in this case, g dash of x is equal to 0. So working out g dash of x, well, if a is just a number, then differentiating, we have 3a x squared plus 2b x plus a. And we've got a stationary point at x equals 2. Okay? So when x is equal to 2, we've got 3a lots of 2 squared plus 2b lots of 2 plus a equals 0. The reason it equals 0 is because, again, we've got the stationary point. So if we tidy all this up, 4 times by 3, that's 12, plus another 1, that's 13. So here we have 13a plus 4b, that's equal to 0. And if we subtract these equations, hopefully you can see a, that's equal to 3. Actually, let's just grab our calculator and solve this. So if we solve our simultaneous equation, with 2 unknowns, we've got 10, 4, 9, 13, 4, 0. We end up with minus, have I got this right? Yeah, we end up with minus 3 and 39 over 4. So here we end up with minus 3 for a and b equaling 39 over 4. And with that, we can conclude that g of x, that's equal to minus 3x cubed plus 39 over 4 x squared minus 3x. And now for part B, we have to prove that the stationary point at 2, 9 is a maximum. So for us to work out whether we have a minimum or maximum, we first of all need to work out the second derivative. So if we work out the first derivative, replacing a with minus 3 and replacing b with 39 over 4, g dash of x, that's equal to minus 9 squared plus 39 over 2 x minus 3, and g double dash of x, that's equal to minus 18x plus 39 over 2. And at the point x equals 2, we've got g double dash of 2, which is equal to minus 18 lots of 2 plus 39 over 2, which is minus 33 over 2. And because this value is less than 0, we can therefore conclude that the point 2, 9 is a maximum. Okay.